Hi, hello, welcome back to Homeschool, Class 10 Mathematics Revision. Today's chapter is Chapter 1, Real Numbers from your textbook. So before starting this chapter, we are going to recollect some tiny concepts like what is a prime number, composite number, co-primes, fundamental theorem of arithmetic. Prime numbers, any positive numbers which are divisible by 1 and itself are all called as prime numbers. Example 2, 3, 5, 7, so on. These are all called as prime numbers. Means these numbers are divisible by 1 and the same number itself. Other than these prime numbers, what we call other numbers? Those numbers are called as composite numbers. Example 4, 6, 8, 10, so on. These numbers will have other numbers as a factors, or these numbers are divisible by other numbers. Not only 1 and itself, other numbers are also divisible. So these numbers are called as composite numbers. You should remember 1 is neither a prime nor a composite number. Right? So next, co-primes. What are co-primes? If you consider any two numbers, those two numbers will have a common factor 1. Then those two numbers are called as a co-primes. Fundamental theorem of arithmetic. Every composite number can be expressed in the form of a prime factors, and every factorization is unique. The order is unique. Right? So coming to real numbers. You have studied before what is real number means. It is a combination of rational and irrational numbers. In rational again, natural, whole, these are all you have read. Right? So let's quickly start first exercise of this chapter. In this chapter we have two exercises. Exercise 1.1. First main. Express these numbers as a product of prime factors. First one, 140. 140. Let's do in the form of factor tree. So take the number 2 70s, right? This is a prime number. So almost right, left side prime numbers. Now for this 70 again. 2 3s are 6, 1 left 10, 2 5s are 10. Then 35 again split this. This can be written as 5 7s are 35. So just you can take square boxes, right? This also you can take square boxes. Now see, these are all the prime factors. So write 140 is equal to, only these numbers you write, 2 into 2 into 5 into 7. That is 2 repeated 2 times. You can write this as 2 square into 5 into 7. That's it. So let's solve remaining problems. 156. 156. What are the factors? Let's start with 3. 3 5s are 15. 3 2s are 6. Then next 52. 2 2s are 4 and 2 6s are 12. Then this one, 2 13s are. Now these are all the prime factors. 156 is equal to, start writing from the small numbers, 2 into 2 into 3 into 13. That is 2 square into 3 into 13. Yes. Next one, 3825. 2 table we can't, 3 we can't, so we can do with 5. So 5 7s are 35. 3 left, that is 32. 5 6 are 30. Again 2 left, 25. 5 5s are 25. Then now again with a 5 table, 5 1s are 5. 2 left, 26. 5 5s are 25. 1 left, it becomes 15. 5 3s are 15. Then again, can you split 153? Yes. 3 5s are and 3 1s are. 51 Again we can write it as 3 ones are 3, 3 sevens are. That is 17 threes are 51. So now observe what are all the prime factors here. 5, 5, 3, 3, 17. So write that 3, 8, 2, 5 is equal to 3 into 3 into 5 into 5 into 17. That is 3 square into 5 square into 17. Next problem. 5005. With the 5 table 1001. Okay. Then this one 7 ones are 7, 30 left, 7 fours are 28, 2 left 21, 7 threes are 21 here. 143, 11 ones are 11, 3 left 33, 11 threes are. Okay. So what are all the prime factors here? 5005 is equal to 5 into 7 into 11 into 13. That's it. Next one. 7429. Oh, I think this is a big number. Small single digits we can't get. So let's move it. 17 table. 17 fours are 68. 68 and here 6 left 62. 17 threes are 51. That means 11 119. 119 means again 17 sevens are 119. So now 437, split it. This is 19 twos are and threes are. That is 1923s are. Therefore finally 7429 can be written as 17 into 19 into 23. Second main, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. So here you should remember HCF into LCM is equal to product of the two numbers. Let the two numbers be A and B I have taken. So this relation you need to verify after finding HCF and LCM. So we have three problems. First one, 26 and 91. 26 split in the form of product of prime numbers. 2 13s are right. 91. Again you can write it as 7 13s are. So HCF, coming to HCF of these two numbers 26 and 91. What is a common number among these factors? 13 is common, right? So this is your HCF. LCM. LCM of 26 and 91 is, write the HCF number first and then write the remaining numbers. 13 into 2 into 7. 13 into 2 sevens are 14. Multiply this. 13 into 14. That is 182. What is your LCM here? 182. Verify with this relation. That is HCF into LCM is equal to product of the two numbers. Let A be 26 and B be 21. HCF is 13 into LCM 182 and what are the two numbers? 26 into 91. Multiply this. 182 into 13. 3 2s are 6. 8 3s are 24. 3 5 and again 182 6 6 2 3 6 6. And if you multiply this also you are going to get 2366. Right? Hence it is verified. Both we are going to get the same answer. Next, second one, 510. 510 and this is 92. 510, let us take separate LCM here. 2 2s are 4 2 5s 2 5s, and again 5 5s are 1s are, again 3 1s are 3 7s are. That is 2 into 3 into 5 into 17. Similarly, take 92. 92, 2 4s are 8, and here 12 left, 2 6 are 12, 2 2s are 2 3s are, then again that's it. So 2 into 2 into 23. Now among these two factors, which are the common factors? Only 2 is common, right? So HCF of these two numbers is 2, and LCM is multiply all the other numbers, HCF number write one time, and multiply remaining numbers 2 into 3 into 5 into 17 into 23. That is 3 2s are 6, 5 2s are 10, 6 10s are 60, 60 into 17 into 23. This is all rough work. So 23 into 17, let us do first. 7 3s are 21, 7 2s are 14, plus 2 16, 23, 1 9 3, 391 we get if you multiply these two, into 60. 6 9s are 54, 18, 23. That is 23460 is your LCM. Now we got HCF and LCM. Let's start verification. H into L is equal to A into B. H value is 2 and L value is 23460. Now let us assume it as A and this as B. That is 510 into 92. Multiply these two. With the 2 multiply. 2 zeros are 0. 2 6 are 12. 2 4s are 8. 9. 2 3s are 6. 2 2s are 4. Now similarly multiply these two. 510 into 92. 2 zeros are 0. 2 1s are 2. 2 5s are 10. 0 9 45 0 2 9 6 4. So now we got both are equal, therefore hence it is verified. Let's see the third problem. 336 and 54. Now write in the form of product of primes here. Do LCM. 336, 3 1s, 3 2s, and again here 2 5s are 10, 2 6s are 12, 2 2s are 4, 2 8s are 16, 2 14s are 2 7s are. Similarly, if I take 54, 2 2s are 4, 2 7s are, 3 9s are, 3 3s are. Now write this with the small numbers. 2 4 times, and then 3 into 7. And now this one, 2 into 3 into 3 into 3. Now HCF of these two numbers. Observe, is there any common number? Yes, 1 2 is common and 1 3 is common. So finally what is your HCF? 2 into 3, that is 6. LCM. First write the HCF number and write the remaining numbers and multiply. 2 3 already finished. Then remaining 3 2s, 2 3s and 7. 2 into 2 into 2 into 3 into 3 into 7. Let us start multiplying this. 2 2s are 4, 4 2s are 8, 8 3s are 24. Right? 7 3s are 21, 21 6 126. Now multiply these two. 126 into 24. 4 6 are 24, 4 2s are 8, 10, 5, 12, 4, 5, 2. Then this is 3024. What is the LCM here? 3024. Now start verification. H into L is equal to A into B. H value is 6, L value is 3024 is equal to 336 into 54. Multiply. 6 4s are 24, 6 2s are 12, 13, 14, 18. Then if you multiply these two also, you are going to get 18144. Therefore, both are equal and hence it is verified. With this, we complete our second main. Third main, find the LCM and HCF of the following integers by applying the prime factorization method. So, in this main, we are having three numbers. We are going to split them in the form of prime factors and then find the HCF and LCM. In this main, we have three problems. First one, 12, 15 and 21. 12 can be written as 2 2s are 4, 4 3s are 12. 15, 5 3s are 15. Similarly, 21 can be written as 7 3s are 21. Now, among these three factors, is there any common factor? Yes, 3 is common, right? So, therefore, HCF of 12, 15, 21 is 3. Then what about your LCM? LCM of 12, 15, 21 is first HCF number multiply the remaining numbers. Multiply 2 into 2 into 5 into 7. That is 2 2s are 4, 4 3s are 12, 5 7s are 35. So 12 5s are 60, 12 3s are 36, 36 plus 6, 42. Therefore, what is your LCM here? 420. Yes, second problem. 17. 17 can be written as 1 into 17. 17 is a prime number. So, there are no factors. So, no factors means if you want, you can write 1 or simply write only 17 there. 23 is also prime number. 1 into 23. 29 is also prime number. So, there is no other number common except 1. Therefore, HCF of these three numbers 17, 23, 29 is 1. LCM. LCM of these three numbers is multiply all the three numbers 17 into 23 into 29. Multiply slowly 23 into 17. 7 3s are 21, 14, 16 and this is 23, 1, 9, 3. Again 391 into 29. Right? 9 9s are 81. 9 3s are 27, 35, 2, 18, 7, 9, 3. This is 13, 11. So, therefore, what is your LCM? 1, 1, 3, 3, 9. Okay. Third problem, 8 can be written as 2 2s are 4, 4 2s are 8. 9 can be written as 3 3s are 9. 25 can be written as 5 5s are 25. Now, among these three, is there any common factor? No common factor. So, what I can write here? HCF of 8, 9 and 25 is 1. Then what about LCM? Multiply all the numbers. That is 2 into 2 into 2 into 3 into 3 into 5 into 5. Or directly you can multiply these numbers also. 2 2s are 4, 4 2s are 8, 8 3s are 24, 5 5s are 25, 25 3s are 75. Multiply 75 into 24, 5s are 20, 30, 5 2s are 10, 14, 15. That is 1800 is your LCM. Okay. Fourth problem, this is important problem in this exercise. Given HCF of 306, 657 is 9. Find LCM of 306, 657. So we know the relation H into L is equal to A into B. Let us assume the two numbers as A and B. We know H, we need to find L. So instead of L, we rewrite the formula as L is equal to A into B by H. Substitute L is equal to A into B, that is 306 into 657 by H value is 9. Okay. 9 7s are 63, 2 left 27, 9 3s are 27. Now what is LCM? Multiply 306 into 73. Just do the rough work aside. 6 3s are 18, 3 3s are 9, 7 6 are 42, 21. That is 8, 3, 2, 2. LCM of these two numbers is 22338. 22,338 is the LCM of 306 and 657. Fifth problem, check whether 6 power n can end with the digit 0 for any natural number n. 6 power n. N is a natural number. Does it end with the digit 0 is your question. Natural number starts from 1, 2, 3, so on, right? So let me take in the place of n, let me take 1. What happens here? 6 power 1 is 6. If I take a natural number 2 in this n place, 6 6 are 36. What is your last digit here? Is it 0? No, it is 6 here. So, will any time does it end with the digit 0? No, I'll say. Why? Observe here. The number what you have is 6 power n. 6, if we split in the form of a prime factors, we are going to get 2 into 3. Suppose if any digit is 5 here, then definitely it ends with the digit 0, 6 power n. So, what you are going to get here? 2 power n into 3 power n. I can say here, no, the 6 power n cannot end with the digit 0 for any natural number. Suppose if you have a 5 here, it ends with the digit 0. See the next problem. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Why it is a composite number is your question. Right. So let us see. Here you have a plus sign. 13 is common. Pick out 13 common. 7 11s are 77. Nothing there here. Common. So what I can write? 1. 13 into 77 plus 1 is 78. Right. If you multiply these two, you will get a composite number. A prime number and a composite number, if you multiply, you are going to get a composite number. If you want, you can split this number also. How I can split this? 78 as 2 3s are 6, 2 9s are 18 and 3 13s are. So observe here, more than two prime numbers, if we multiply, we are going to get a composite number. So yes, it is a composite number. Why it is a composite number? It is a product of two prime numbers, or the product of two numbers, we get a composite number. It is a composite number. And in this you have one more set. 7 into 6, 5, 4, 3, 2, 1 plus 5 there. Again 5 is common. Pick out 5 common. 7 into 6 into 4 into 3 into 2 into 1 plus 1. Right. So now multiply all this. 3 2s are 6, 6 4s are 24, 7 6 are 42 into 24 plus 1. If I multiply 42 into 24, what we are going to get? 4 2s are 8, 16, 2 2s are 4, 8, and this is 1008, 1008 plus 1, 5 into 1009. Therefore, Again, it is a product of two prime numbers, then it is a composite number. Therefore, yes, it is also a composite number. Right? See the last problem in this. There is a circular path. There is a circular path around a sports field. You imagine a circular path. Sonia takes 18 minutes to drive one round of the field. Who is the person here? Sonia. Sonia takes 18 minutes to go around the circle, while Ravi takes 12 minutes. Sonia takes 18 minutes, Ravi takes 12 minutes. For the same, suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Suppose both of them starting here, okay, going down this circle. Sonia and Ravi started here. Sonia takes to complete one round 18 minutes. Ravi takes within 12 minutes. Like this they are running round and round and round. But after some time, both of them will meet at the first point. What is that is your question. Right? What we are going to do here? We are going to find the LCM. Sonia 18. 18 split in the form of prime factors. 2 9s are 18, that is 2, 3 into 3. Okay. Then again 12. 2 2s are 4, 4 3s are 12. Now what is common in these two? That is 3 2s are 6 is common. So LCM means common numbers write one time and then write remaining numbers 2 into 3. That is 6 6 are 36 minutes. After how many minutes? After 36 minutes, Sonia and Ravi meet at the starting point. This problem write with the verbal statements. With this, we are going to complete our first exercise. Exercise 1.2. In this, we have 3 mains and very easy exercise and very important exercise. Among these 2 problems, one we can expect in your annual exam. The numbers may be changed, but one question is compulsory. What is your heading? First one, prove root 5 as irrational. Root 5 itself is irrational. How can I prove it as irrational? First, let us assume. What we are going to do? Let us assume root 5 as rational. I am going to say in an easy manner such that you never forget. Alright? So, root 5 I need to prove irrational means first opposite I will take. What is that? Let us assume root 5 as rational. If it is rational, it should be in the form of P by Q or A by B, where A and B are co-primes and B cannot be equal to 0. Those all you need to write the statements. Right? So, if root 5 is a rational, root 5 must be equal to A by B. This is a rational number. Right? Now, what I have to do here? You need to write where A and B are co-prime and B is not equal to 0. First, squaring on both sides we need to do. Root 5 whole square is equal to A by B whole square. Root 5 whole square is 2, square root cancel, 5 and this will be A square by B square. Send this side, 5B square is equal to A square. Observe here carefully. If I transpose 5 this side, that means what is happening here? 5 divides A square. According to your theorem in this chapter, what I can say, if P divides A square, then P also divides A. So, same you write here. If 5 divides A square, then 5 divides A. Okay. Now, in place of A, I will assume any number that is with what number you have? 5. Right? 5C or 5K or 5M, anything you can take. I am taking here 5C. So, now substitute this A value here. 5b square is equal to 5c whole square. 5b square is equal to 5 5s are 25c square. Right? Cancel. 5 5s are 25 cancel. B square is equal to 5c square. That means what happens here? If 5 comes this side, 5 divides b square, then automatically what I can say? 5 divides b. Therefore, 5 divides a and b. What I can say here? Therefore, 5 divides a and b. To become root 5 as a rational number, a and b should not divide any other number other than 1. Therefore, it is dividing, right? Therefore, what I can say here? Therefore, my contradiction or my assumption is wrong. Therefore, root 5 is a irrational. That's it. So, let's see once again. Prove root 5 as irrational. Let us assume root 5 as rational. If it is a rational, it should be equal to a by b. Root 5 is equal to a by b, where a and b are co-primes and b cannot be equal to 0. Squaring on both sides, root 5 whole square is equal to a by b whole square. That will be 5 equal to a square by b square. Cross multiply here, 5b square equal to a square. Then what I can say? 5 divides a square, then 5 divides a. In place of a, take 5c. In place of a, see what number you have, that number into c you take. A is equal to 5c. 5c substitute here. 5b square equal to 5c whole square. 5b square equal to 25c square. Cancel b square equal to 5c square. Now 5 divides b square, then 5 also divides b. Therefore, finally what I can say? Therefore, 5 is dividing a and also b. No other common factor should be there for a and b, but we have here 5. Therefore, finally, my assumption is wrong. Root 5 is irrational. Right? Same manner, we can take any number, children, here. Suppose let me take here 2. Prove root 2 as irrational. Same things you write. Instead of 5, you say 2. Let us assume root 2 as rational. Root 2 is equal to a by b. Squaring on both sides. Root 2 whole square equal to a by b whole square. Root 2 whole square will be 2. 2 is equal to a square by b square. 2b square equal to a square. 2 divides a square. Then 2 divides a. Again, in the place of a, what I have to write here? What number you are assuming? Root 2, right? So, 2c. 2b square is equal to 2c whole square. 2b square equal to 4c square. Cancel. You are going to get b square is equal to 2c square. Then now again, 2 divides both a and b. Therefore, root 2 is irrational. Same manner, you can write root 3 as irrational, root 7 as irrational. One format you remember, children. Any number you can use same format. Change the numbers. Second one, prove 3 plus 2 root 5 as irrational. So what we are going to do here, same manner. First step, let us assume 3 plus 2 root 5 as a rational number. Right? If it is rational, what I need to do? 3 plus 2 root 5 is equal to a by b, where a and b are co-primes and b is not equal to 0. Now, observe here carefully, where is a root number? Root 5 you have, right? Other than root 5, remaining numbers and other side. That is, 2 root 5 is equal to a by b plus 3. It becomes minus 3. Do LCM. A minus 3b by b. And extra what you have here 2. That 2 also send that side. Root 5 is equal to a minus 3b by 2b. This is irrational. This is irrational. Both cannot be equal. Yes or no? Therefore, that only you write. A minus 3b by 2b is rational. And root 5 is irrational. Right? Both cannot be equal. My assumption is wrong. Therefore, you have to write these all statements. Therefore, my contradiction is wrong. Both cannot be equal. Therefore, finally, what you have question? 3 plus 2 root 5 is irrational. That's it. Right? Hence it is proved. See the third main. This also prove irrational. Same manner. First step. Let us assume 1 by root 2 as rational. Right? So if it is rational, what I should do? 1 by root 2 is equal to a by b, where a and b are co-primes. B cannot be equal to 0. Now, where is the root 2 here? Right? Cross multiply. B is equal to root 2a and root 2 is equal to b by a. Now, same manner what I can say? B by a is rational. Root 2 is irrational. Both cannot be equal. My assumption is wrong. Therefore, finally, 1 by root 2 is irrational. That's it. Hence, it is proved. Now, see the next one. Same manner. Let us assume 7 root 5 is a rational. Okay. If it is rational, what I should do? 7 root 5 is equal to a by b, where a and b are co-primes. B is not equal to 0. Now, other than root 5, what do you have extra? 7. Root 5 is equal to a by 7b. Now, same manner, a by 7b is a rational. A by 7b is rational. Root 5 is irrational. Therefore, finally, my assumption is wrong. What is assumption? Rational number we have assumed. No, that is wrong. Therefore, 7 root 5 is irrational. Hence, it is proved. Last one. 6 plus root 2. Again, this one also same manner. Let us assume 6 plus root 2 is rational. Okay, if it is rational, equate to a by b. And say a, b are co-primes, so b is not equal to 0. And now root 2 one side, remaining all other side. Root 2 is equal to a by b minus 6. Do LCM. Root 2 is equal to a minus 6b by b. Now what you will say? A minus 6b by b is a rational. A minus 6b by b is rational. And root 2 is irrational. Both cannot be equal. Therefore, finally, 6 plus root 2 is irrational. That's it. Write neatly stepwise statements. With this, we complete our real numbers. Problems are very easy, children. Practice carefully. In our next video, we are going to start with another new chapter. Until that, thank you.